Hi, this is Austin. This is take two for Lab 1, Rotary to coordinate. So we are going to utilize Python to create a program that asks for one of two different sets of input, angle of servo and length of arm, or X and Y coordinates. So the program will output an X and Y coordinate or an angle of servo and suggested arm length. So as you can see, we have our 3D printed little plate over here. These little green icons over here are X and Y coordinates. For example, this one might be kind of hard to see. 50 is X, 0 is Y. And this one, 69 is X, 40 is Y. That is that little black square notch over there. We also have two different arm lengths over here that we're going to test. Okay, let's switch over the screens. So this is our CAD file over here, just mapping out the angles over here. 60 degrees is from the axis over here, the x-axis, up to these little tabs over here. 30 is same thing, x-axis to these little tabs on this little peg. And here is our Python program. We just going through it roughly. We import math, throw everything in the loop. XP is input for user input. So that's what the user is going to type in. And we communicate first things first, what the user wants to do. If they want to go from X and Y coordinates to angle, type yes. Otherwise, type no to go from angle of servo to XY coordinates. Otherwise, if they don't want to do anything and they just want to quit, they can just type exit as well. So if they hit yes, type in yes and press enter, it'll ask for X and Y coordinates, and it'll do the math over here. It'll calculate length of arm, best suited to reach that X and Y coordinates, and the degrees of freedom, or sorry, degrees of rotation, theta. And if they type no, they can go from angle of servo to XY coordinates. So yeah, there's more calculations, radius, and we utilize the math module to bust out the cosine and the sine. All right, so let us do the first test. So we'll type yes because we want to go from XY coordinates to angle of servo. All right, so enter X coordinates. So let's see. How about we do this one right here, this notch over here. So X is 69, Y is 40, and so we'll type in 69, enter, 40 for Y, enter, and it calculates the best length of arm that's ideal to reach that X and Y coordinates. Degrees of rotation as well, 30 degrees, and that matches up with our CAD calculations over here. So that covers that. And program continues. Let us type in no, because we're going to test the other function. We're going to go from angle of servo to XY coordinates. So enter length of arm. So let's double check. I believe we're using the small arm. So that small arm that's on the plate right now, that is 50 millimeters. Okay, so 50, enter, enter angle of motors in degrees. So let's do this 60-degree angle. We're gonna try for this little notch over here, this coordinate over here, 25 in X and 43 in Y. So let's type in 60 degrees, and then it spits out coordinates for that length of arm and that angle. It shoots out 25 and 43. And that checks out right there, 25 and 43. Okay, so next, let's try swap out the arms to the longer one. I believe the next one is 80 millimeters. There we go. So I'm thinking, try that 40 and 69 one again, or we could go 0 and 50 at 90 degrees. All right, let's go back to the code. All right, so we'll type in no, enter length of arm, 80 millimeters, enter motor angle. You know what, should we just do a 90? Let's see what happens when we go 90. So because it's 80 millimeters, it should reach this other notch over here, this 0.80. Let's see. So we'll type in 90 degrees, spits out coordinates, x equals 0, y equals 80, and that is correct right there. Just to double check, let's try to do the 4069 over here. So that one is at 60 degrees. So we'll type in no again, enter length of arm, we're still at 80 millimeters, and enter angle, we're at 60 degrees. All right, and it spits x equals 40, and y equals 69. Right there. Okay, so that concludes the first lab. And yep, that's it. Thanks for watching.